Our next topic is square law AM detector. The process of extracting the original signal from the modulated wave we call as the demodulation. That will be performed by the demodulator or detector. So now we discuss about the square law AM detector. Okay, so in this we using square law device LPF, low pass filter. Yes, right. So here the input of this detector is the AM wave. Okay, so that is represented with V1 of t. Okay, so that will be given to the square law device. Okay, so next the output of this one is V2 of t, and the V2 of t is passing through the LPF filter. Okay, so this will be tuned for the FM. Okay, the output of this one is V0 of t, that is proportional to the our M of t. So now here you see, so the components here we using square law device and LPF filter. Yes, right. Square law device. So here semiconductor devices or transistors are used as the square law devices. Yes, right. That is diodes and transistors are used as the square law devices. Okay, due to the transfer character here, that diode will perform the square law operation. Okay, now V1 of t is the AM signal, that is modulated signal. Okay, so that will be represented our standard AM equation, AC into 1 plus Ka M of t into cos 2 pi fct. So that will be passes through the our square law device. Okay, so that will be squared by this device. Okay, the input V1 of t, and that is represented in terms of the V2 of t. Okay, so that V2 of t is passing through the our low pass filter. Okay, it will be allow only low frequency signal. Okay, remaining all are rejected by the our LPF. Okay, now V1 of t is equal to standard AM signal, that is AC into 1 plus Ka M of t cos 2 pi fct. Okay, V2 of t is nothing but output of the square law device. Okay, so that is A1 V1 of t plus A2 V1 square of t, where A1 A2 are the constants. Okay, V1 is the standard AM wave. Okay, now substitute our V1 of t in V2 of t. Okay, so then V2 of t equal to A1 into V1 of t. V1 of t is AC 1 plus Ka M of t cos 2 pi fct, plus next A2 into V1 square. Okay, A2 into V1 is AC 1 plus Ka M of t cos 2 pi ct whole square. Okay, so then the equation becomes, okay, V2 of t equal to A1 AC, okay, 1 plus Ka M of t cos 2 pi fct, plus A2, okay, AC square, next 1 plus Ka M of t whole square into cos square 2 pi fct. Yes, right. So that is 1 square 1 plus Ka square m square of t plus 2 Ka M of t, 1 plus Ka M of t whole square, that is A plus B whole square. Okay, A square plus B square plus 2AB. Okay, so then expand this equation, then V2 of t equal to A1 AC 1 plus Ka M of t cos 2 pi fct, plus A2 AC square, okay, into 1 cos square 2 pi fct, plus next A2 AC square. Okay, next to Ka square M square of t cos square 2 pi fct. Okay, next coming to A2 AC square into 2 into Ka M of t cos square 2 pi fct. Okay, next we know that trigonometric equation cos square theta equal to 1 plus cos 2 theta by 2. Is right. Cos square theta equal to 1 plus cos 2 theta by 2. Yes, right? Okay, so then a1 ac 1 plus ka m of t cos 2 pi fct plus a2 ac square 1 plus cos 2 theta is 4 pi fct by 2 plus a2 ac square. Next ka square m square of t 1 plus cos 2 pi fct by 2. Okay, sorry, here is the 4. Okay, next plus 2 ka a2 m of t. Next ac square 1 plus cos 4 pi fc2. Next expand this equation, then v2 of t equal to a1 ac cos 2 pi fct plus a1 ac ka m of t cos 2 pi fct. Straight a1 this one, this into, and this into this one. Okay, next plus a2 ac square by 2 plus a2 ac square by 2 cos 4 pi fct plus ka square by 2 m square of t ac square a2 plus ka square by 2 m square of t a2 ac square cos 4 pi fct plus ka a2 m of t ac square plus ka a2 m of t ac square cos 4 pi fct. Okay, so here we know that m of t is the message signal, modulating signal, so that is am cos 2 pi fmt. Okay, so where here this a2 ac square by 2 is the dc signal. Okay, and a1 ac cos 2 pi fct, so this one is the fc term. Fc term is high frequency term. Okay, so this will be rejected by the our lpf. Okay, not allowed by the lpf filter. Okay, next a1 ac ka m of t cos 2 pi fct, so here also high frequency term, this one, this also not allowed by the our LPF. Okay, next a2 ac square by 2. Okay, cos 4 pi fct. Okay, so this is also high frequency term, this will be blocked by LPF. Okay, next coming to ka square by 2 m square of t a2 ac square. Okay, so this will be allowed by our LPF, but we having some distortion at the output, so that's why LPF this will be rejected. Okay, next ka square by 2 m square of t a2 ac square cos 4 pi fct. Okay, so this is also not allowed by the our LPF. Okay, so next ka a2 m of t ac square. Okay, so this signal is our desired signal. Okay, our FM signal. Okay, so that is nothing but low frequency signal, modulating signal. This will be allowed by the our low pass filter. Okay, so this term also rejected by the our LPF. Okay, so this DC signal and this signal both are allowed by the our LPF. Okay, so this will be blocked by the our capacitor. Okay, this DC signal will be blocked by the our capacitor. Okay, so only we having the output v0 of t, that is the output of the LPF, so that is ka into a2 m of t ac square. Okay, so this is nothing but where m of t is multiplied by some scaling factor, that is a2 ac square ka. Is right? Okay, so this is v0 of t is proportional to our m of t. Okay, so this is our output modulating signal, versional message signal. Okay, so for reconstruction of the versional message signal, here we using the LPF filter. Okay, for modulation purpose we using the band pass filters. Output of the LPF filter is our modulating signal, low frequency signal, this one, and its spectrum is, so m of t is time domain. Okay, so by applying the Fourier transform to this m of t, that will be converted into m of f frequency domain. Okay, m of f, that is from minus omega to plus omega, or minus fm to plus fm.